All right, so in our directions, it tells us to reduce all fractions, round all percents to the nearest tenth, and money to the nearest cent. The following data was recorded at a local basketball court based on 200 shots. So we're calculating the experimental versus the theoretical probability. So what is the experimental probability of someone making a free throw? So experimental means that we are using the data that we got from 200 shots. So the free throws is this 38 out of 200 total shots. I'm going to make sure that doesn't reduce, so 38 divided by 200 and times 100 for percentage, so it's 19%. What is the experimental, so based off the data, of making a basket? So free throws are baskets, three-pointers are baskets, other baskets are 100. So you would have to include all of those values in making a basket. So 38 plus 30 plus 100. So that's 168 out of the total 200. So 168 divided by 200 times 100 for percentage is 84%. What is the experimental probability of making a three-pointer or a free throw? So three-pointers are 30 and a free throw is 38. So this is 68 out of 200. 68 out of 200 equals 0.34 times 100 is 34%. What is the experimental probability of not making a free throw? So anything not a free throw, 32 plus 30 plus 100. Would be 162 out of 200 is 0.81, 81%. Okay, so if I'm going back, and now we have a bag of marbles. So using a bag of marbles containing 4 white, 3 black, 6 green, and 7 blue marbles, answer the following questions. So first I want to see how many total marbles. So 4 plus 3 plus 6 plus 7 gives you 20 total marbles. Okay, what is the probability of randomly drawing a white marble? So white marbles are 4 out of 20. Replacing it, so you put it back, and then drawing a blue marble. Okay, so replacing it and getting a blue, so blue is 7 out of 20. So we take 4 divided by 20 times 7 divided by 20. They want it as a fraction, so I do math, enter, enter, and it's 7 out of 100. What is the probability of randomly selecting a black marble? So that's 3 out of 20, and then another black marble. So now we already got one of them, so there's only 2 left, and there's only 19 marbles total. So we take 3 divided by 20 times 2 divided by 19. Math, enter, enter, is 3 out of 190. And the reason why this is 2 is because you already got one. You already drew that one black marble. So that's why there's only 2 black marbles left and there's only 19 total. What's the probability of randomly selecting a blue or white marble? So we have to add together the blue, which is 7, and the white, which is 4. So that's 7 plus 4 equals 11 out of the 20 total marbles. Just to make sure it doesn't reduce, 11 divided by 20, and you click Math, which is right here, enter, enter, and that's correct. It doesn't reduce, it's just 11 out of 20. What's the probability of randomly selecting a green and a black and a blue? So the first time you're selecting a green is 6 out of 20, and so we're multiplying. A black, so that'd be 3 out of 19 total, and a blue, that's 7 out of 18. Because each time we're not replacing it, at least doesn't tell us we are, so our denominator is decreasing. So to multiply this, 6 divided by 20 times 3 divided by 19 times 7 divided by 18. Math, enter, enter. So it's 7 out of 380. Create a Venn diagram to display the following information. We're talking about males, females, and seniors. So I need 2 circles. And I'm going to do females and seniors. Because I have this overlapping area of female seniors, that's 70. We know there's 185 males, so anything not in that circle has to add up to 185, and 90 total seniors. If we already have 70 seniors here, this part would have to add up to 20. 185 males, so that means this part and whatever's out here would have to add up to 185, so that'd be 165. And then there's 400 total, so I would add these all together. So 70 plus 20 plus 165, and then subtract it from 400. That means 145 go here. So 185 males, let's just check. 20 and 165 does give me 185. 70 female seniors, the female and the seniors is 70. 90 total seniors, and then 400 total. So yes. What is the probability of selecting a non-senior male? So a not senior, so it's not in this thing, and it's a male. So it's got to be 165 out of 400, which I take the percent. 165 divided by 400 is 41.25%. What is the probability of selecting a female or a senior? So the females are this 145 plus this 70. That's the female portion. And then the seniors also include this 20. So 145 plus 70 plus 20 gives you 235 out of 400. So if I take 235 divided by 400 times 100 to get my percentage is 58.75%. What's the probability of selecting a non-senior female? So these are my senior females, so my non-senior females is this 145 portion out of 400. So 145 out of 400 times 100, 36.25%. What is the probability of selecting a non-senior out of the females? So you're only looking at the female portion. So it's just the 145 plus 70. That's my total. And then non-seniors. So these are my seniors. My non-seniors are 145. So 145 divided by 215 times 100, 67.44. And we know to round it up to the nearest tenth. So really, all of these should have been one more decimal place. I like 2 decimal places, so I'm going to use that. Tree diagram model. Statistics were calculated from last year's STAR test as following. 76% passed English 1, 92% passed biology, 65% passed algebra 1, and 88% passed U.S. history. Draw a tree diagram. All right, so for English, you can either pass or English fail. So English passing is 0.76. So to get this value, you're subtracting from 1. So 1 minus 0.76 is 0.24. Then after you've taken the English, you are taking the biology. So your biology you can either pass or biology you can fail. Biology you can pass or biology you can fail. So for passing, it's 0.92. So to find the percent failing, you would take 1 minus 0.92, and we get 0.08. Then you have your algebra 1. So algebra pass, algebra fail. Algebra pass, algebra fail. Algebra pass, algebra fail. Algebra pass, algebra fail. So for my algebra passing, it's 0.65. So to figure out what it is for failing, 1 minus 0.65 is 0.35. Lastly, we have U.S. history. So U.S. history pass, U.S. history fail. 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 So passing is 0.88. And then failing, 1 minus 0.88 is 0.12. And so forth. So passing all exams. So passing this one is 0.76. Passing this one is 0.92. Passing this one is 0.65. Passing this one is 0.88. You multiply those all together. 0.76 times 0.92 times 0.65 times 0.88 times 100 to get my percent is 39.99%. Okay, passing English and biology only. So English is passing, so 0.76. Biology is passing, 0.92. And then algebra is failing, so 0.35. U.S. history is failing, so 0.12. Because we only pass those two. So we take 0.76 times 0.92 times 0.35 times 0.12 times 100 is 2.94%. Passing at least biology. So that means you are passing biology, so that's a 0.92, and all of the other ones, it doesn't matter. So your percentage is just 0.92%. Failing all. Okay, so failing English is 0.24. Failing biology is 0.08, 0.35, 0.12. So I took all of my failing, 0.24 times 0.08 times 0.35 times 0.12. All my failings, multiplied them together, and we got 0.08%. Expected outcome. What is the expected number of girls in a family with 12 children? So the probability of having a girl is 1/2. Out of 12 total children equals 6. A carnival game's first prize probability is 0.0625. Second prize probability is 0.25, and third prize probability is 0.425. If 400 players attempt the game, about how many of each prize should the carnival expect to award? So we're taking 0.0625 times 400 for my first prize. We have about 25 first prize. Okay, then the probability of 0.25 out of 400. You have about 100 people to get second. And then 0.425 out of 400 is 170 that would get third. You and some friends go to a maze. You can choose to head to one of 3 different clue stations to finish in a winner's circle. What is the probability of losing? So I need to create an area model. Okay, so from my start, I can go A, B, or C. So I need to break this into 3 even portions. A, B, and C. In clue A, there are 3 different routes. Let me get my colored pencils. One of these is winning. Two of these ends. Okay. From clue B, you have only 2 directions. You can either win or you can end. From clue C, you have 3 options. 2 go to win. And 1 goes to end. So I need to have a least common multiple. So this would be 3 times 2, which gives you 6. This would be 2 times 3, which gives you 6, and then 3 times 2, which gives you 6. So each of these break into 2 parts. Each of these would break into 3. Each of these would break into 2. Okay, what is the probability of losing? So losing is my blue. 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of 6 plus 6 plus 6 is 18 total boxes. So that is 1/2. What is the probability of winning? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Which is 1/2. What is the probability of losing via clue C? So clue C and losing is 2 out of 18 total paths, which is 1 out of 9. What is the probability of winning and choosing clue A? Choosing clue A and winning is 2. It's 1 out of 9. Expected payout in fair games. A player is charged $3 to play a game. A dice is rolled, and if you roll a number greater than 4, you will win $1.50. If you roll a 1, you will win $3. Okay, so it's 1 dice, so there's 6 total options. If you roll a number greater than 4, so that'd be 5 and 6. So 2 out of 6 options, you win $1.50. Plus, if you roll a 1, so that's 1 out of 6 options, you win $3. So 2 divided by 6 times 1.5 plus 1 divided by 6 times 3. So the expected total payout is $1. So is this a fair game? You're paying $3 to play. So no, it is not a fair game. So the house profits, if you're expecting to pay out $1, but they're paying $3 to enter, is a $2 profit. If the house charged $5 per player, what would be the house profit or loss if there were 200 players? So it's a $2 profit per person times 200 players would equal $400 total dollars of profits. A beanbag toss game is played at our carnival. Each player will get 3 tries. Assume the players have a 50-50 chance of hitting the target. If you hit the target 3, you win a $3 stuffed animal. And this would be 3 times. If you hit the target once or twice, you receive a 40-cent candy bar. And if you miss on all shots, you get no prize at all. What is the average expected payout per player? All right, so if you hit the target 3 times, you win a $3 stuffed animal. So the odds of hitting it 3 times, so it's 1 out of 2, 1 out of 2, 1 out of 2. So the odds of hitting it 3 times is 1 out of 8. You get a $3 stuffed animal. If you hit the target once or twice, so that means if you hit it once, that's a 50-50 chance. Or if you hit it twice, that's 1/2 times 1/2, which is the 1/4. So that's 3/4 times 0.4. And if you miss on all shots, you get no prize at all. What is the average expected payout per player? So 1 divided by 8 times 3 plus 3 divided by 4 times 0.40. 0.675, which you can't pay that in money, so 0.68. Given the probability of winning a game is 5 to 17, what are the odds in favor and the odds against? So the odds in favor is 5 to 12. Against would be 12 to 5. Given the odds against a horse winning a race is 5 to 4, what is the probability of the horse winning the race? So the odds against is 5 to 4, so that means the odds of winning is 4 out of 9. So remember your formulas, because it says against, this is the top number. When it says 4, this is the top number. So make sure you know the difference. If it's against, the top number is the second one. If it's 4, the top number is the first one. Given the odds in favor of winning are 1 to 8, what are the odds against? So the odds against would be 8 to 1. and the probability of winning the game. So that would be 1 out of 9 total of winning.